People have always looked at the heavens for inspiration, but a small firm in Boulder, Colorado, looks at the skies in a different way.
Morning, Ann.
For over 25 years, Stratton Park Engineering Company, or SPEC Incorporated, has been creating innovative instrumentation to help collect and validate atmospheric research data.
The best way to, in the long term, to determine climate change is from satellite data, because the satellites are always spinning around the Earth and collecting data continuously. But they need some kind of a reference and what we call ground truth. So our instruments were up in the clouds measuring the shapes and sizes of ice crystals and cloud particles.
The technology for SPEC's Cloud Particle Imager, or CPI, was developed jointly under Small Business Innovation Research, or SBIR awards from NASA Langley Research Center and the National Science Foundation. As aircraft fly through the same clouds that are being imaged by satellites, the CPI takes high-speed digital pictures of the minute crystal particles that move through its probe and records them on a computer hard drive. The characteristics of the particles can determine whether sunlight gets through the clouds and warms the Earth's surface, or if it bounces off and cools the Earth. The CPI has been installed on aircraft all around the world, including NASA's WB-57. SPEC's 2D stereo probe, known as 2DS, uses laser beams to capture two-dimensional images of cloud particles. 2DS has also flown on a number of major field campaigns by NASA and the National Science Foundation for hurricane and cloud studies. Another instrument developed with SBIR funding from Goddard Space Flight Center sends a laser pulse out and looks at photons as they are scattered by cloud particles. SPEC's in situ LiDAR will play a crucial role towards validating NASA satellite data. The instrument measures cloud properties out to almost a kilometer from the aircraft.
Now, the reason this is important is that satellites that look down at clouds typically have a pixel size of about a kilometer. So they don't see the individual particles or even what's going on inside of this kilometer pixel. So what we do now is we measure the properties of the entire kilometer. We get average properties.
The company is now developing extremely small instruments that can image cloud particles continuously for up to 30 hours. This makes them suitable to fly on unmanned aerial vehicles, or UAVs. UAVs can gather data from places where typical manned aircraft can't fly, and many scientists see these aircraft playing a large role in the future of atmospheric research.
We are developing a sensor under the NASA Wallops SBIR program to be installed on very small UAVs. We call this a micro CPI. And again, like the CPI, it measures the properties of ice crystals and water droplets, records the data on board the small UAV, and also telemeters it back to users on the ground.
SPEC's ultimate goal is to help researchers better understand what's going on inside the clouds and improve predictions of the Earth's climate, an understanding that benefits us all.